You have successfully built a machine learning model. Your data scientists are celebrating. However, the reality is that getting a model into production is where 70% of AI projects fail, not because of bad selection of algorithms, but because of poor operations. Welcome to MLOps, Machine Learning Operations, the discipline that bridges the gap between model development and real world deployment. And as a project manager, you don't need to write a single line of code to be the guardian of this critical process. Hi, I'm Rajiv Das, and in this video, I'm going to show you exactly what you need to monitor at every stage of the ML ops pipeline to ensure your AI projects doesn't become another failed showcase project. So, first, let's get clear on what MLOps actually is. If you are familiar with DevOps, the practice of automating and monitoring software development, MLOps is its machine learning cousin, but with some critical differences. Traditional software is deterministic, same input, same output. But ML models, they are probabilistic. Performance can degrade over time, data changes, the real world evolves, and the data pattern changes. That's why MLOps adds three critical layers to traditional DevOps. Continuous training. Models need to be retrained as data evolves, as the data pattern changes. Model needs to be monitored. Performance tracking in production is a must. Data versioning. Code changes, but so does your training data. As a project manager, your job isn't to build the pipeline, it's to ensure these processes are in place, monitored, and improving. Let's break down exactly how. The MLOps pipeline, your project management checkpoints. The MLOps pipeline has six critical stages. For each one, I'll show you what you need to monitor and what questions you need to ask your teams. Stage one, the data pipeline. This is where raw data is collected, cleaned, and prepared for model training. Stage one, the data pipeline PM checkpoints. Data quality matrices. What percentage of incoming data is clean versus rejected? Set acceptable thresholds. Data freshness. How old is the data when it reaches the model? Latency matters because if your model is trained on old data, your predictions will go wrong. Data versioning. Is every dataset versioned, tagged, and traceable? You need this for regulatory compliance and debugging. Schema validation. Are data types and formats consistent? Because maybe your underlying data set changed from maybe number format to string format, or maybe from date to number. So you need to be aware if there is any data changes, because schema drift breaks models silently. The key PM question to ask here is, how will we know if our data quality drops below acceptable levels? If your team can't answer this instantly, your project has a blind spot. Stage 2, model training and versioning. Your data scientists are training models, possibly dozens of experiments without proper tracking. You lose reproducibility. So the PM checkpoints in this stage are experiment tracking. Every training run logged with hyperparameters, datasets used, and performance matrices should be logged so that you can trace back what parameters were used and which datasets were used to train your model. Then you need to maintain a model registry, a centralized repository of all trained models with metadata. Think of it as version control for models. Then you need to have a baseline comparison. New models must beat the current production model by a defined threshold. You should not be guessing what is your current model performance. Only if your current model performance is better than your production model, you need to go and deploy that model. Training cost monitoring. Cloud compute for training can explode budgets, so you need to closely monitor your budget and track it. The key question to ask in this stage is, can we reproduce any model version from 6 months ago if needed? This isn't theoretical. Regulatory audits will ask exactly this question. Stage 3, model validation. Before any model touches production, it must pass rigorous testing, not just accuracy, but fairness, robustness, and business alignment. The PM checkpoints in this stage are performance thresholds. Define minimum accuracy, precision, recall you need to achieve during your model training. Document who approved this. Next, you need to do testing for biasness. Bias testing is also a very important checkpoint in model training. Run fairness audits across demographic groups. One bias prediction can sink your project and it can bring bad name to your organization. You need to scope for edge cases testing. What happens with unexpected inputs, malformed data, how outliers are handled. Your model needs to fail gracefully. Business metric validation. Technical accuracy doesn't always equal business value. Validate against actual business KPIs. The actual business KPIs which you define in the initiation phase of your project, in the business understanding phase, those acceptance criteria should align with your model performance. The key question to ask here is what's our rollback plan if the model underperforms in production? You need an answer before deployment, not during a crisis. Stage 4 deployment. This is where models go live, but in MLOps, we never deploy directly to all users at once. The key checkpoint questions here are what is your deployment strategy? Canary releases or friends and family launch to a small percentage first. Blue green deployments is another strategy, or deploy in shadow mode so that the new model runs but doesn't affect users yet. Infrastructure readiness. Can your servers handle the inference load? Latency requirements are met? Do you have your monitoring dashboards in place? Real time performance tracking operational before deployment and not after deployment. Rollback procedures. One click rollback to the previous model version. Practice this, perform dress rehearsals seriously. Key PM question in this stage is how long does it take to revert to the previous model if something goes wrong? If the answer is hours, you are not ready for production yet. A pro tip, start with a canary deployment to 5% of users, monitor for 24 to 48 hours, gradually increase. This catches issues before they become disasters. Stage 5, model monitoring. This is the most critical PM checkpoint. Models deployed is not the finish line, it's the starting line. Models degrade, data changes, the world evolves. The data pattern changes. The PM checkpoints here are performance matrices. Track accuracy, precision, recall, F1 score in production. Compare to training benchmarks daily. Data drift detection. Is incoming production data statistically different from training data? Drift equals to degrading performance. Prediction distribution. Are model predictions still balanced? Sudden spike in one class suggests issues. So you need to revisit your model. Latency monitoring. Is the model responding within SLA requirements? For example, if your response SLA is say, less than 100 milliseconds, is it performing as per that SLA or maybe less than 1 second? Resource utilization, CPU utilization, memory utilization, GPU usage, optimize or scale as needed. Business impact matrices, conversion rates, user satisfaction, revenue impact. It is important to consider these matrices as technical matrices don't pay the bill. The key PM question to ask here is how quickly can we detect a 10% drop in model performance? If it's more than a few hours, you have a monitoring gap. The last stage, the stage 6, the continuous training. Models need to evolve with the world. The business changes. This stage completes the loop. The key PM checkpoints here are retraining triggers. What would trigger your model retraining? Define when retraining happens, whether it's what is the schedule, what is the cadence, whether it's weekly, monthly, performance threshold crossed, significant data drift detected, automated pipelines. Can retraining happen automatically or does it require manual intervention? So you need to define these strategies. Retraining cost. How much does each retrain cycle cost in cloud compute and budget accordingly? Champion challenger testing. New retrain model competes against production model. Better performance, you go ahead and deploy. Worse, you investigate. So the key question for project managers to ask here is what's our cadence for model retraining and who approves production updates? Define this in your governance document from day one. So this is our 6 stages of MLOps pipeline. data pipeline, model training, model validation, deployment, monitoring, continuous training. Before we wrap, here are the MLOps red flags that should make you stop everything and investigate. If you are saying we are not tracking that, in if any checkpoint I mentioned earlier isn't being monitored, your project is flying blind. If you are saying we'll set up monitoring after we deploy, no. Monitoring infrastructure is deployed with the model, not after. Data drift, our data never changes. Every model experiences drift. Denying it doesn't make it go away. We can't reproduce that model. If you can't recreate a model from 3 months ago, you have a governance issue. Retraining takes weeks. In production, you need the ability to retrain and redeploy in days, not weeks. So these aren't technical issues, they are project management issues, and they're your responsibility to fix. Let's recap what we covered. MLOps is the discipline that keeps ML models reliable in production. As a project manager, you own 6 critical checkpoints: data pipeline, model training, model validation, deployment, monitoring, and continuous training. You don't need to code. You don't need to tune hyperparameters, but you do need to ask the right questions, set the right thresholds, and ensure your team has the right processes in place. Because the difference between a successful AI project and an abandoned one, it's not the algorithm, it's the operations. If you found this video helpful, hit the like button and subscribe for more AI project management content. And drop a comment. What's your biggest MLOps challenge? Thanks for watching. Now go ask your team these checkpoint questions. I will see you in the next video. Until then, stay AI savvy, stay ahead.